to E-Yantra technologies. In this present video, we are going to learn how to do the experiment number 7, that is interfacing of stepper motor with Arduino. This is the lab for Jntuk ECE 3rd year 2nd semester R20 regulation, Arduino and ARM based lab. It is the experiment number 7, which is the interfacing of stepper motor with and controlling with analog pins. So in this experiment we are going to learn how to do this. Let's open the sketch. In the files provided to you, the stepper with pod control tested working is one such file. Just click on the file and open it. This will open the Arduino sketch, and in this sketch we are going to control the pod, that is, we'll turn the potentiometer and we'll try to move the stepper motor. See, this is the standard sketch available in Arduino. You don't have to use any extra libraries. Of course, this is a built-in library. You don't have to download anything. And here first thing is include stepper.h. This is a built-in file, header file. You don't have to download any other library. And here we define steps per revolution. The motor which is supplied in EYT M2 model, E-Yantra Technologies model number 2 board, it comes with 32 steps per revolution. The motor which we have supplied is this. If you are using a different one other than the kit supplied by us, you have to choose a different value. And now we are constructing a constructor stepper, a constructor class with name stepper, that is also called as stepper. And here there are 5 variables to be supplied to this class. That is, first one 32, which is number of steps per revolution, and this 5, 7, 6, 8. Please copy them as they are. Don't ever try to edit, because on the board that we have supplied to you, the order is 5, 7, 6, 8. What is this 5, 7, 6, 8, you may ask? Please pay attention here. In this case, we have some text written over there like stepper. You can remove the jumper clips here if you want. Even with the clips, you can see C4, the pin C4 is getting connected to D5, Arduino's digital 5, and C3, the coil 3 of the stepper motor, is connected to D6, C2 with D7, and C1 with D8. So this is the way we have connected it. And there are 4 coils in the stepper motor. 4 coils. Coil number 1, coil number 2, coil number 3, coil number 4. And if you want to turn the stepper motor, you need to power the coils in a particular sequence. And if you power the coils 1 and 3, it will go in one way. 2 and 4, it will go in the other way. So that sequence is required. That's why to satisfy that sequence, we are using the order which is mentioned in this code as 5, 7, 6 and 8. Please don't change these numbers. If at all you type 5, 6, 7, 8 or 8, 7, 6, 5, it will go totally random. So please don't play with this. And how the motor is driven here? Actually, in this stepper motor, we need a buffer called ULN 2003, which is already built in. So inside the board itself, on the back panel, you are going to see the stepper motor. I think you can see some glow inside. Let me show this. Yeah, some red light is glowing inside, which is the stepper motor LED, which you may not see clearly, but at least you can see some red thing inside. So that stepper motor module is there, which is driven by ULN 2003, which is a stepper motor driver. That module is there. Why the module is needed? Because you cannot run this stepper motor. See here, there is a wing attached to see whether it is rotating or not. So this stepper motor comes with a current rating of about 200 to 300 milliampere per coil. So it is going to draw that much high current, as a result of which Arduino cannot deliver this much current. So Arduino can hardly deliver a current of 20 to 30 milliampere per pin. Hardly 20 milliamperes you get. That is also not safe. So how to get this much current? Actually, it is powered by USB. So our USB port is capable of delivering up to 500 milliamp. Any standard USB port, any computer can deliver up to 500 milliamps. So as it is 200 to 300 milliamp drawing motor, we power the motor from USB power only. Arduino is not powering, but Arduino pin is not capable of delivering the so-called 200 to 300 milliamp current. So what we do is we use buffers, Darlington buffers. Darlington buffers are used, and 4 such Darlington buffers are required. That's why we are using a IC module which is ULN 2003. So that buffer is driving this stepper motor from the back side of the board. Connections are already there, and the buffer controls, that is the input pins to these buffers, are controlled by Arduino. So Arduino is not controlling the buffers, but Arduino is not controlling the motor, but it is controlling the buffer, and buffers are giving current to this stepper motor. This is the way the circuit diagram is designed. Now, without changing anything on the pin, we are trying to control the things with port, either port 1 or port 2, whichever you want. You can use in the software. You can just choose the pins. So here I am trying to control it with port 1. So whenever I turn the port like this, my stepper motor also moves in a similar fashion. When I turn it, it goes back. So this is analog pin controlling the stepper motor. That is what asked in the question. So controlling of the stepper motor using analog GPIOs. Analog GPIOs means you are taking the analog input and then controlling the stepper motor. So let's see how it works. So in the code given here, this is the stepper constructor, and then they have taken a variable called int previous. So they have initiated an integer with 0 named previous, and first of all you should start serial.begin. See, this serial.begin is only to print statements. Here we'll be printing how many steps it is moving in the serial monitor. Apart from that, there is no other use. And stepper set speed. This stepper object set speed is a function. Maximum value is 1100. You can go up to 1100. That is the maximum top speed of the stepper motor. Actually, it moves pretty slow. Number is high, but it moves pretty slow. So the set speed is, it can be 30, 40, it can be anything. But for the given motor, it is 900. The best one is 900. And setup is done. Just we are initializing the serial module and we are starting the stepper, and then we have come to this get val. See, get val is a function. Here we have used a variable, floating point variable named val, and initialized to 0. And get val is a function. I am using a val function. It is my own created function. It is not the built-in one. So here I did something which I'll come to in a moment. This get val is a function opened here and it gets closed here. So we'll call this a little later. Now let's come to loop. So in the loop, first thing what we do is we call this get val function. It does something, and then serial.println val means whatever value that it gets, it actually prints over there. Then stepper.step. See, this is the important point. This stepper.step, it is an integer value. How many steps I have to move? How many steps I have to move? See, here I am subtracting val from, I am subtracting previous from val. I'll come to it in a moment. First let me clear this, what is val business. Previous is already 0 earlier. So val minus 0 gives you val only. So val is a value. So stepper moves by this many steps, which is equivalent to val. Val value, whatever it may be, that many steps it is going to move in the stepper motor. Next, these are comments you don't have to use, only this one. Previous is equal to val. Now we are reinitializing. Earlier previous was 0. Now after this point, let us say if the val was, for example, 100. Previous is 0. So 100 minus 0 is 100. It will go 100 steps here. And then now I am saying previous is equal to val. So this time, now previous is no longer 0. I am equating it to val. Means my previous value will be 100. So just I am comparing what is the previous position of the potentiometer. That's why I am subtracting from this one. And then the code is over. Just next line will be end statement. These are just comments. They are not useful. Only you see the curly braces. So only these curly braces complete the program. The double slashes are all comments. They won't execute. So clearly you can see a function is getting the value, printing the value, and then stepper.step, that value minus the previous. That's all. And reinitialization of previous. Only these 4 lines are happening here. Now comes to the get val. What is this get val? Actually, I want to get the value of analog value from the pin, that is from the pot. Now come back to get val. So we have initiated a value named val equal to 0, and in this get val we are running a for loop. What this for loop does? Basically this for loop is running for 40 times. You can see it's starting from 0 and going up to 40. Less than 40 means up to 40 in steps of 1. You can see val, which is 0 initially, is equivalent to val plus analog read A2. See, on our table, on our board we have A2, that is the pin A2. You can see the pin A2 here. You can see here pin A2. This A2 is actually connected to port 1. Please see this in the middle of the screen. A2 is connected to port 1. So it means if I am turning the port 1, my analog value at A2 will automatically change from 0 to 1023. That's what I am trying to measure now. So what I'll do is, here in this code I am trying to measure my analog value. See why I am doing this. Initially value was 0. So first time when the for loop runs, 0 will be added here. So 0 plus analog read. So first trial it measures the value of something and then comes out of the for loop, and once again I gets increased, I equal to 1. So once again the previous value whatever it is measured, to that it will be adding the new analog read, and once again comes out of the for loop and increases the I equal to 2, I equal to 3, I equal to 4, so on. It is going to add the analog read values 40 times. So it means it takes the average value. See, I could take direct analog read value itself, but the problem is the analog read values are so noisy that if you measure right now it may give 512, next moment it may give 510, 515, like that it is fluctuating. So this is not good to take a direct value, rather to take a smooth average value. So I am taking the average value of 40 readings, and those 40 readings, once again after completing the for loop, it quits the for loop after this 40 times, and that value, whatever value it has measured, val slash equal to 40. So it is nothing but value is equal to value divided by 40. So we are taking the average value. So finally after this process, that is if you get the function called getVal, your val variable, your float value val will be returned with the average value, of the analog read. So simply after you run getVal, you get some val as average value, and that value you are feeding it to the stepper. Initially when you turn the pot, the stepper will go to that particular step, and when you once again do any change in that, either the step increases or step decreases. If at all it decreases, the value will be negative. If at all it increases, the value will be positive, and accordingly the stepper motor will move either clockwise or anti-clockwise. Let us upload the program and see how it behaves. So Arduino Nano COM3 as usual. So whichever COM port you get, just try to upload it. Now the uploading process is going on. Once after successful completion of uploading, we will see. It's taking time. Just be online. It's taking time. Yeah, it's now compiling, and then it starts uploading the sketch in a moment. Yeah, it's now uploading and done uploading. And see, the pot has turned, the stepper has turned little bit. See, when I turn the pot, it's turning back clockwise, it's going clockwise, anti-clockwise, it's going anti-clockwise. Like that, when I turn the pot, accordingly it moves either clockwise or anti-clockwise. So we have tried to control this with the help of a software. Thank you.